My name is Ari Brown. I'm a software engineer at Nordstrom, and I'll let Jack introduce himself too.
I'm Jack Burns. I am a software engineer on the data streaming platform at Nordstrom, and we will be talking about orchestrating a Kafka migration using Temporal.
Cool. So first we're going to talk about what this Kafka migration actually is. And we want to preface this by saying this is not a Kafka talk, this is a Temporal talk, but there are a few key concepts we're going to go over so that everyone has context for this Kafka migration. And so the first thing we're going to go over is what is Kafka? Kafka is an open source data streaming platform. It consists of topics, which are basically storage space for messages. And it also has clusters, which are groups of servers that manage data. We're also going to mention consumers, which read messages from topics, and then producers, which produce messages to topics. We're also going to talk about our platform that we currently have at Nordstrom. So we have an internal platform at Nordstrom that's responsible for all data streaming. This is a tier 0 system, which means it's a system in which other systems are built upon. And this is critical to a lot of business processes at Nordstrom. And so we need our platform to be very reliable with no data loss. Our platform currently has 5 Kafka clusters, over 200 teams using the platform, and over 10,000 topics. And so this migration was no easy feat. It was a large coordination effort between hundreds of teams and thousands of topics. Next, I'm going to talk about the platform we're going to migrate to. So this is Confluent Cloud. It is a cloud-native platform that offers Apache Kafka as a service. It's fully managed, which means it offers things like provisioning, maintenance, and scaling. These are all handled by the Confluent Cloud team. So the Nordstrom platform team can focus more on building and deploying applications. And so ultimately what we want to do is migrate our Kafka topics from the self-managed Kafka platform to this new Confluent Cloud platform. Next, we're going to talk about our dreams of a perfect migration. And so when we were dreaming of what would make this migration go smoothly for not only our clients, but also us as a platform team, we came up with this checklist. And so the first two, zero data loss and minimal client downtime. Once again, this is a tier 0 system, and so with this migration, we can't afford to interrupt business processes. We also wanted this migration to be client managed, which means we wanted clients to be able to really drive the migration and remove the platform team from being a possible bottleneck for this migration. We wanted the migration to be automated and visible, so we wanted our clients to be able to see what state their migration is at any given point. We also wanted the migration to, we wanted clients to be able to assess migration readiness. So before migrating a Kafka topic, there's a list of prerequisites that they needed to complete before they could even migrate their topic, and we wanted a way for them to automatically be able to see what prerequisites they'd completed and what they still needed to complete. And finally, we wanted to offer our clients a familiar user experience. So migrations are already stressful enough. We don't want to inundate them with a bunch of new tooling or required learning to even do the migration. And next, we're going to talk a little bit about what this Kafka topic migration actually looks like. So 2 tools we used was topic mirroring and the Confluent replicator. The job of the topic mirror is to create a read-only replica of one topic and create this topic in our new Confluent Cloud cluster. This also syncs things like access control, consumer offset, and other configurations. And so basically the purpose of the topic mirror was to mirror data from our original topic to this new Confluent Cloud topic. And then the Confluent replicator is basically a reverse mirror. So the purpose of that is to replicate data from the Confluent Cloud topic back to the original topic on the old platform. And we're going to briefly step through what this Kafka migration actually looks like. So first we have our original topic with 1 producer and 2 consumers. This is the topic we're going to migrate to Confluent Cloud. Next, we're going to introduce our topic mirror. So this is where we're mirroring data from our original topic to the new topic on Confluent Cloud, and also syncing things like what I said, configuration, access controls, consumer offsets. Next, we're going to wait for replication lag to reach 0. So basically, the mirror topic this topic mirroring is an asynchronous process. So when we first introduce this mirror topic, there's going to be some lag when it's mirroring the data over, but eventually that lag is going to reach 0. And so at that point, we can start moving our consumers over to the new Confluent Cloud cluster. After that, the topic owner will promote the topic, which basically changes this mirror topic from a readable topic to also a writable topic. So at this point, that means we can start moving our producers over to produce to this new Confluent Cloud topic. And also, if our clients choose to, they can add in this Confluent replicator. And so here we can see the replicator is replicating data back from the Confluent Cloud topic to the original topic. And a use case for this is if we have straggling consumers, which basically means that if for some reason our clients can't yet migrate their consumers from the original cluster to the new Confluent Cloud cluster, they can still read in the data that's coming in from the Confluent Cloud topic that's replicated back to the original topic, so those consumers can still read that new data. And this phase can go on for an indeterminate amount of time as long as our clients are not yet ready to migrate their consumers over. And this is the last stage of the migration. So we have fully decommissioned our old topic. We have our new topic and its producers and consumers all on the Confluent Cloud cluster. And so next I'm going to talk a little bit about how we got to use Temporal as a tool. So when we were originally planning for this migration, we didn't first choose to go with Temporal. We had an idea to use gitops. And this is what that gitops migration workflow would have looked like. So first, the user assesses their migration readiness, and then they create a merge request. The platform team then has to manually review that merge request and merge it in. And then that merge request, once it's merged, is going to kick off a pipeline that would run, that would create a mirror topic and a lot of other stuff. And so you can see from this workflow that there's a lot of back and forth between the user and the platform team. There's a lot of manual steps that the platform team has to take. And so this workflow is not ideal because the platform team could potentially be a bottleneck if the user is waiting for the platform team to do these manual steps. And also, this is definitely not scalable for the over 10,000 topics that we have to migrate. And so if we refer back to our dream migration checklist, this GitOps workflow accomplishes a couple of our requirements, but definitely not all of them. And so we decided to scrap this GitOps idea and work with Temporal. So now I'll hand it over to Jack to talk about why we chose Temporal and then how we used it for our migration.
Thank you, Ari. How do I use this? All right, introducing Temporal. So as Ari mentioned, we didn't start with Temporal as a solution. So how did we get here? Topic migrations can run for an indeterminate amount of time, an hour, a day, a week, a year even. So we needed a technology in which we could easily model those long-running topic migrations. As you all know, this is trivial to do with Temporal. Migrations need to be durable and idempotent. We're talking about production data on tier 0 systems. So unhandled failures as well as inconsistencies can lead to extended client downtime, data loss, and in the worst case scenarios, significantly impact Nordstrom's ability to actually operate as a business. We talked about how visibility was something that was really important to us. With Temporal, you get out-of-the-box visibility into workflows, their state, and their metadata. Temporal's flexible deployment strategy, as well as the fact that workflows and activities are just code at the end of the day, makes it really easy to integrate with existing systems and architectures. And this ended up being very important to us, and we'll talk about why a little bit later on. So let's meet the workflows, right? We've talked a lot about them. The first one we did was our migration readiness report workflow. So I already mentioned wanting to provide users with a way in which they could easily assess their migration readiness. The migration readiness report workflow determines the readiness of a topic to migrate based on a set of prerequisites. These prerequisites are primarily metrics-based, pulled from a number of sources, including Prometheus, Confluent Cloud, and our self-hosted Kafka clusters, and then actually returns to the user a report with a list of actionable tasks that they need to take in order to prepare for their migration to Confluent Cloud. So the next workflow is the topic mirror migration workflow. This is kind of the meat and potatoes of the whole migration process, and it models the life cycle of one of these topic migrations. As you can see on the right in the workflow history, it does a lot, and this kind of repeats. But at its core, at a high level, it really just creates a read-only topic mirror. It examines that mirror topic lag and then some other metrics to ensure that a topic is ready to migrate to Confluent Cloud, or ready to be promoted to Confluent Cloud, rather, and then promotes that mirror topic to a writable topic. So our third workflow is the topic replicator workflow. This is an entity workflow that models the lifecycle of a Confluent replicator. It's launched as a child workflow of that topic mirror migration workflow, and it's used for reverse mirroring to handle that straggling consumer use case. So after introducing Temporal, let's see how our migration flow changes. At this point, the platform team is sitting in a room with users and actually manually executing workflows. But you can see that the weight of the migration is slowly starting to shift onto users and off the platform team. There's still this coordination that needs to happen, and this is absolutely not scalable for over 10,000 topics. Referring back to the checklist, when we introduced Temporal, we were able to automate the internal workings of the migration process. So creating that topic mirror, promoting that topic mirror, and then actually launching the Confluent replicator. We were able to provide out-of-the-box visibility for the platform team. And then we were able to allow users to easily assess their migration readiness with the migration readiness report workflow. As we talked about, this is not client managed. The platform team is still too heavily involved, and it is far from a familiar user experience. The final puzzle piece. One of the reasons why we chose Temporal, as I touched on, was it's very easy to integrate into existing systems and architectures. To get away from this manual execution of workflows on the behalf of the users, we needed to integrate Temporal into our existing platform UI and API. We actually did this by mapping workflows to API resources. So we introduced a topic migration resource as well as a topic migration report resource, made those available through the API, and then modified the UI to display those resources to the user. And then I wanted to take a second also to talk about deployments. One of the reasons Temporal is so easy to integrate into systems is because of its flexible deployment strategy. We were able to deploy our workers using Nordstrom's standard deployment pipeline for containerized microservices, meaning that we didn't have to go out and build custom solutions for connectivity, security, and observability. We got our company's flavor of deployment for free with no additional charge using Temporal, and that's just huge. So now we want to show you a little example of what this integration looks like from the experience of the user, from the point of view of the user, rather. So if you're a user of our data streaming platform and you want to migrate a topic to Confluent Cloud, the first thing you're going to do is actually run a migration report. And this is the real example of a migration report. As you can see, this user has some work to do in order to prepare their topic to migrate to Confluent Cloud. On the back end, the API is actually just executing a migration report workflow and asynchronously grabbing the result, returning it back to the user through the UI. Say you're a manager, right? And you want to see all of your team's migrations completed and running in one place. You would come to your team's migration page. Now, this migration page, under the covers, we're actually just executing a workflow list and then filtering by team ID, which is a search attribute that we attach to every one of our migration workflows. Now, what happens if you are interested in diving a little deeper into one of these individual migrations? Then you'll find yourself on a migration details page. Now, here you can see more in-depth information about a topic migration, such as what cluster the source topic currently lives on, what cluster in Confluent Cloud we want to migrate the topic to, as well as where we are in the migration process. There is a big pink promote topic mirror button in the top right corner. I wonder what happens when we click that. You are prompted to start promoting your topic mirror. And you also can choose to elect to enable a reverse mirror. What's cool about this is that this manual process of promotion now becomes the full responsibility of the user, and there's no intervention by the platform team, right? Behind the scenes, we are sending a workflow update to the running migration workflow, and this unblocks the workflow so that it can move through that promotion process. Okay, so you've promoted your mirror topic. What next? Once you've promoted your topic, your producers and consumers can move over to the topic in Confluent Cloud, and you are ready to complete your migration. So that promote topic mirror button in the corner has now changed to a complete migration button. When we click that, we send a workflow cancellation signal to the running workflow, and that cancellation cascades down to all child workflows, and cleaning up any migration resources, and then eventually deleting the source topic. And then your migration is done. So let's revisit what the flow looked like before integrating Temporal into our existing platform UI and API. And then how does that change after the integration? I hope this works, by the way. This is my favorite slide if it works. It's supposed to be a little video. Oh, that didn't work. Well, so if this doesn't work, imagine that all three of these things shift up to the top, right? So the idea is that we move these manual stages and we've embedded them into the UI. And the migration process now becomes entirely user-driven and initiated, right? Aside from answering questions, there's no longer any responsibility of the platform team. So visiting back to our migration checklist, after integrating Temporal into our existing platform UI and API, we have now created a completely client-managed offering, migration offering, and we've provided a familiar experience to our users so that they can build confidence in their migration. They're not out learning new tools and technologies. So everybody check under your seats, you get a bonus workflow, right? All right, so there was an ask from executive leadership, to create a dashboard to help them evaluate the progress and success of the topic migration. This was easy because we were actually able to source all the data that we needed to build this dashboard from Temporal. So we made a Temporal scheduled workflow that pulls metadata about running migrations and then uses this data to populate the migration KPI dashboard. By using the search attributes that we added to all of our migrations, we're actually able to join to existing data sets and allow users to filter on attributes such as director, manager, and VP, right? So this is a big business win for us. It provided immediate value, and it was easy as pie because we had all the fundamental building blocks there because of Temporal. So Ari, how's it going?
Yeah, so 1 month into the migration, we have 10% of our topics migrated, which is around 1,000 topics. The migration is completely self-service. So like Jack said, since we were able to integrate the temporal workflows into our UI, it's completely user managed. And we also were able to do some performance tuning on our temporal workers. For future plans, we have a couple more workflows in development. So we have a notifications workflow that's going to be able to send notifications to our users at key points in the migration workflow. We also have our Kafka connector migration workflow, so that's going to help us migrate our topics over from our old cluster to the new Confluent Cloud clusters. And since we had so much fun and Temporal was so easy to use, we have a lot more time to develop Confluent Cloud specific features.
We thought we might share a couple of lessons that we learned along the way and with this project. And the first one was polling versus event-driven, right? So when we first started writing these topic migration workflows, we got stuck in this pattern of polling, right? Polling external metrics, polling systems to determine when we're ready or not ready to do something or take an action. This ended up being actually really expensive because we're using a lot of temporal actions when we don't need to. And it created a poor feedback loop for our users. They have to wait an entire poll interval in order to have what they want reflected, right? And so we were able to save some money and provide an event-driven experience for our users by using some of the more event-driven temporal primitives like signals and queries. Signals and updates. Also, a big win for us was search attributes, oddly enough. It's not something you think about, but visibility was super important. And by having search attributes, we were able to provide enhanced visibility for not only the platform team, but also the users. And it was pretty much the unlock for us for the migration KPI dashboard, right? We were able to join to other data sets, as well as we could just do a workflow list and not have to introspect on every single one of our workflows to get the data we needed.
Another big lesson learned was publishing data models. So we had 2 different applications interfacing with Temporal. And so we decided to publish and put in output models. And this allowed for more versioning and synchronization between those 2 applications that were interfacing with Temporal. And then finally, iterating was a big one. So realizing that, like developing a workflow, realizing it wasn't maybe optimized in the best way or what we really wanted out of that workflow, and giving ourselves the time to refactor that workflow. That's going to save us a lot of time in the future, so we don't have to bootstrap like thousands of workflows that are already existing. Yeah.
All right.
Oh, thank you so much.
That is it. Anybody have any questions?
Thank you.
A question, raise your hand. I'll bring the microphone to you.
Thank you.
May I assume your platform team was using gitops for infrastructure as code? If so, how will you close the feedback loop? Like how will you write the new resources on the gitops after that?
So, could you repeat your question? Sorry, I'm not sure I heard the first part.
Yeah. May I assume your platform team is using GitOps for infrastructure as code? If so, how will you close the feedback loop? Like how you write those on GitOps after the migration? Have you thought about that?
We haven't thought too much about replacing the existing provisioning of our infrastructure. But maybe it's something that we do in the future. I think for this use case, it was easy because we didn't have a good pattern already, and we're also having to repeat it 10,000 times in a short period of time, as opposed to, you're provisioning things like, you're provisioning the actual clusters. It's something you don't do all that often. So.
In a lot of your workflows, everything was very one directional as far as the migrations went. I'm wondering how you go about undoing things. For example, like, oh, something messed up in the replicator. I've got to maybe restart or whatever that is. Like, what does that kind of look like?
Yeah, so that's a good question. At this point, we just pray. No, we don't have a great pattern, honestly. I think that's something we're working on right now. I think part of the reason is because you give users a little too much of a safety net, and they don't feel like they can fail forward, right? So with this topic mirroring strategy, we make it easy to have parity between both clusters. Once you promote, though, there's not really an easy way to roll back without manually intervening. So, but that's definitely something that we probably should take a look at because it's happened a few times.